All right, welcome to the Explainer. Today, we're diving into an absolutely massive paradigm shift in how we build software and automate workflows. We are moving way away from those traditional node-by-node workflow builders and stepping right into the era of dynamic, thinking Agentic OS platforms. We're going to explore how you can build full-stack, enterprise-grade applications without writing a single line of code, just by having a conversation with an AI. It's a real game changer. Okay, let's dive into this. Here is our roadmap for today. First, the Agentic OS era. Second, MCP, the Universal Remote. Then we'll cover the BLAST framework, starting with Blueprint and Links, moving right into Architect and Stylize, and finally, Trigger and Automate. All right, first up, Section 1, the Agentic OS era, and how we're moving beyond static workflows. So the landscape of building AI systems, it's fundamentally changed almost overnight, largely thanks to platforms like Google's Anti-Gravity and Claude Code. Think about the old way for a second. Using traditional workflow builders like Zapier and NNN, you were essentially just gluing specific steps together. You had to map everything out node by node, manually handle every single error, and honestly, you were locked into a single rigid path. But the new way, using an Agentic OS, it's entirely different. You simply ask the AI to build the system for you conversationally. And it gets better. These new platforms actually feature self-healing code and parallel thinking agents that can work on different tasks all at the same time. The source material perfectly hits the nail on the head with a great analogy. Having an Agentic OS is literally like hiring a brilliant 500 IQ intern. But this intern isn't just fast. They can run 5 to 8 independent parallel agents at the exact same time. You no longer have that single agent bottleneck. You just tell them what you want, and they figure out all the intricate routing to make it happen. Moving right along to Section 2, MCP, the Universal Remote, connecting the AI to the world. Okay, so we've got this super smart intern, right? But how do they actually interact with your other software? How do they break out of their isolated little bubble? Well, that brings us to the Model Context Protocol, or MCP. Think of MCP as a universal remote control for your AI, because without it, your brilliant 500 IQ intern is basically locked in a room without a laptop or Wi-Fi. They are incredibly smart, sure, but entirely powerless. MCP bridges that gap, allowing the AI model to connect directly to and actually execute actions within external applications. And the integrations are just vast. You can connect to Notion, Fireflies, Supabase, GitHub, you name it. By establishing what the source material calls a virtual handshake through MCP, your Agentic OS can dynamically read your meeting transcripts from Fireflies, pull out the action items, and push them straight into a Notion dashboard completely automatically. Which brings us to Section 3, BLAST, Blueprint and Links, the scaffold of your app. Now that we have the engine and the connectivity, how do we actually build the application itself? We use a core cognitive scaffold known as the BLAST framework. It's made up of 5 really precise phases: Blueprint, Links, Architect, Stylize, and Trigger. And listen, whether you're building a simple internal dashboard or a massive full-stack app, every single project has to follow these exact steps to ensure the whole shebang doesn't just fall apart the second a customer tries to use it. Let's break down that first step, the blueprint phase. This is totally rooted in the philosophy that the problem we solve is way more important than how we solve it. You have to define these 5 criteria using natural language, your North Star, or your desired outcome, your integrations, your source of truth or database, the final delivery payload, and your behavioral rules, which are basically your logical constraints. Bottom line, if you give the AI bad instructions here, you are absolutely going to get bad outputs. Next up is the link step. Once the AI understands the blueprint, it needs to validate its tools. This phase ensures the system can actually communicate properly with apps like the Reddit or YouTube APIs, or your Supabase backend, before it writes a single line of code. It's essentially the AI reaching out, touching, and feeling those external systems to ensure that virtual handshake is completely solid. All right, into Section 4, BLAST, Architect and Stylize, building the engine and the paint job. With the logic planned and the connections verified, we get to the real meat of the build, the architect phase. We use a really smart 3-layer architecture here that separates reasoning from execution. First, we have the architecture layer, utilizing technical SOPs written in Markdown. Then we have a navigation layer for routing data, which acts as the reasoning layer. And finally, the tools layer, which executes the specific actions using deterministic Python scripts. Now, here's a crucial concept to wrap your head around. Large language models are probabilistic, meaning if you ask them the same question 100 times, you might get 100 slightly different answers. But you absolutely cannot have an enterprise app that behaves differently every time a customer clicks a button. Business logic must be deterministic. By using those structured SOPs in the architect phase, we literally force the AI to be reliable, predictable, and consistent every single time. Once it's working flawlessly under the hood, we move to the stylized phase. Doing the job is one thing, but looking great while doing it, that's another. The source material talks about this fantastic technique called UI sniping. This involves grabbing code for premium components, like really beautiful chat windows, high contrast borders, or sleek dark mode interfaces from libraries like CodePen or 21st. This ensures your app looks like a premium top-tier product and not a cheap $2 suitcase. And finally, Section 5, trigger and automate. Deploying your AI system. So we have this beautifully designed functional application running locally on our machine, but now we need to trigger and automate it out into the real world. Depending on what you need, you might push your code to GitHub for version control, host it on Vercel so you get a live URL to actually share with clients, or deploy your backend scripts to Modal. And deploying to Modal is incredibly powerful. It means your app just keeps working whether your laptop is open or closed, autonomously scraping subreddits or checking your emails every 3 hours on a serverless schedule. To speed up this entire development cycle, we introduced something called Claude Skills. These are custom, reusable AI commands that automate repetitive developer workflows directly from your terminal. For instance, with just a single / command, you can trigger a complex skill that automatically clones a competitor's website layout, completely swaps out their images using the Nano Banana API, and redeploys a fresh, unique version. It turns these complex multi-step actions into a single keystroke. It's wild. But as you start building these massive interconnected systems, here is a crucial pro tip to remember. 50. You want to keep your active MCP tool usage under 50. If you give the AI access to too many tools at once, it severely impacts the model's memory and performance, leading to a frustrating phenomenon called context rot. So what exactly is context rot? Well, it happens when the AI's context window gets so overloaded with history and tool data that it forgets its initial instructions and just gets stuck in a thinking loop. But it's easily solved. Simply ask the AI to summarize its current progress, grab that summary, and open a completely fresh window with a clean context. Or you can just switch the AI pilot altogether. If Claude is getting stuck, you just swap the pilot over to Gemini to get a fresh perspective and push right through the error. We've covered a ton of ground today, seeing exactly how the BLAST framework takes us from a blank screen to a fully deployed, deterministic AI system. By utilizing an Agentic OS and MCPs, the technical barriers to entry have virtually disappeared. The tools are here, they are incredibly powerful, and they are controlled purely through conversation. So I'll leave you with this provocative thought. If you can build anything you can imagine, what are you going to build first? Thanks so much for joining me on this explainer, and I'll see you next time.